Alright guys, you lucky home users missed the first 5 minutes of lecture. Thanks to your dumb professor who forgot to press the record button. So be sure to review the notes. And we're just about done with the first chapter. So to define a variable, you give it a type. And I know you asked this, what is the limit? So I'm absolutely sure we've seen this slide before. We finished this PowerPoint entirely. Okay, fine. All right, thank you for reminding me that. Let's go and look at the last slide, see if it looks familiar. Yes, it does. All right, I'm sure it didn't hurt to have repeated the last. Okay, so we're done with Chapter 1. I'm not going to post a quiz over Chapter 1, but I do want you to read it. So the parts of a C++ program. Here's our sample. Comments. We don't use hashtags, we use double slashes. A lot of languages follow this paradigm. Java, JavaScript. A comment is something that you add to the program just for your purpose, not for the purpose of the computer. So a program will work if it doesn't have any comments, but if you come and look at it a year after you've written it and you didn't put any comments in it, you're not going to have a clue as to how it works. And if you work on a team with other programmers, you absolutely better put comments in there, or they're not going to know how it works, and they're going to probably delete your code and rewrite it to their own ends, and then you're going to look at it and wonder, okay, anyways. So do comment your code. For example, at the top of every code that you write you submit to me, I'd like for your name, and the date. Then there are preprocessor directives, which I know we've talked about. They begin with the # symbol, hash octothorpe, as the British call it. And what they do is they manipulate what happens when the program is compiled. This means that when the program is compiled, that file, Iostream, will be pulled from whatever library it's in and inserted into the text of your source code for compilation purposes. Now, is your code permanently modified in the process? No, they're really both copied somewhere else for that to happen. Without this line, then our cout and our arrow stuff's not going to work. That's what Iostream does, is it gives us the ability to write to the screen and to read from the keyboard using these symbols and using cout and cin. So preprocessor directives, at least # include directives, are used to bring in libraries. They bring in code that you can then use in your own. And then using namespace std. Why don't we go ahead and make a little bit of a program just so that we can demonstrate what happens when we start taking these things out, how it breaks our code. So we're just going to type in like a very, 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 very short program. Eventually, you're going to get tired of typing in the same stuff over and over and over. So what I recommend you do is just to create what I call boilerplate and save it to your desktop so that you can open it and paste, copy and paste every single time. So what am I doing? I'm doing File, New Project, C++, empty project. I'm going to give it today's date, February 1. Now that makes a project, but it doesn't put any source code into it. So if you can't find your Solution Explorer, if it got closed, it's not a disaster. You just have to open it up. You go under View. The View menu shows Solution Explorer. So now I have it back. I'm going to right-click on Source Files, and I'm going to add a new item. I could just call it source CPP, or I could give it, the same name as the project, February1.cpp. Just don't put a space in the names of your program files. And this is in fact a CPP file and not a .h file, so I'm going to make sure CPP is selected. It was. And then I'm going to click Add, and Visual Studio helpfully creates my empty file and puts it under there in my project. Just as a reminder, if you can't find this stuff on your disk, it's easy to find if you right-click on the solution name and do Open Folder in File Explorer. So when you're ready to upload your stuff or you want to copy it somewhere else, do that. Okay, so our boilerplate stuff. Everything I'm typing right now is what I consider boilerplate because you add it to every program you write. # include Iostream, like input-output stream. And then using namespace std, and then int main, parentheses in parentheses, curly brace, close curly brace. And now I'm going to put those two lines that I always put at the bottom of the program. The Mac users can skip the line system pause, system parentheses, quote, pause, end quote, end parentheses, semicolon. But Mac users cannot skip this line, which is return 0. Now let's actually put some stuff in here. This is going to be a real dumb program. We'll modify it to do something better in a bit. Int age. Now let's write out a message. Cout less than less than. How old are you in years? Now let's let them type into the age variable. So CIN arrow the other way, greater than age. And now let's add to that variable. We're going to say age is equal to age plus 1. And then we're going to print one more message out. I'm going to delete some of the white space to make it all fit on screen, and then I'm going to wind up, generally shrinking it as we go. So cout less than, quote, next year you will be end quote, semicolon, cout, arrow, age, without any quotes, arrow, quote, space, years old, exclamation mark, \n. The \n does the same thing that ENDL did the last time we did this. I'm going to remove the \n and I'm going to go ahead and use ENDL. So now this says cout, arrow, age, arrow, quote, years old, exclamation mark, end quote, arrow, ENDL, not END1, ENDL. So there's our program. Might even work. To test it, I'm going to go to Build, Rebuild Solution. Show output. Rebuild all succeeded. If there was a mistake, it would show up in the error list. I'm going to make a mistake. I'm going to take out a semicolon. You don't need to do that. You don't need to add errors. But I'm going to build it again, rebuild solution. And now I get an error list. If something's wrong, you can double click on that error and it'll show you hopefully what line it's on. Hopefully it'll also underline the point of the error. Sometimes you have to kind of look. Maybe the error was really on the line above it. And in this case it was, right? My semicolon should have been here, but it's underlining that. Why is it underlining that? That's spelled correctly. It's because there wasn't a semicolon on the line above it, but this is the first point where it noticed it. So I'm going to put that back in there. OK. Find out if it works. I get tired of answering this, would you like to build it? So I'm going to click do not show this dialog again. But if you ever get the message, program has errors, do you wish to run it anyways? Never choose yes. And certainly do not choose yes and say do not choose this dialog again, shows this dialog again. You never want to run it if there were errors. Always fix the errors. All right, so yes, I want to build it. All right, so how old am I? I'm 32. Next year, you'll be 33. I'm glad I have this computer here to tell me these things. So here we go. We have our program here. Now we're going to start taking parts of it out, and we're going to see what breaks. Well, if I didn't know what that line was for, so I deleted it. I'm not going to delete it. I'm just going to comment it out. You don't need to, but what it means is that I would have to fix all of these words, cout, cin, and endl. I would have to go and put std : in front of them. I'm going to go ahead and make that change. std : in front of each thing that it underlined once I commented that out. All right, so that cluttered it up, right? I don't like looking at that nearly as much with all the colons there. So that's why we put that line in there. But I won't even leave a but. That's the purpose of this, is when we do using namespace std, if there is anything in the std namespace, we don't have to precede it with its name, as long as that's active. But without it being active, I did have to put that stuff there. And again, that'll make more sense later. I just want you to kind of get used to the idea of what that using namespace means. Is it means that, okay, everywhere there should have been an std : it's okay. If I had that there, we wouldn't have had to put that stuff there.
So is that like importing a library in Python?
It's not the importing the library. Very good question. If you remember in Python, you had two ways of importing things. You had import turtle, or I'm going to make up a different name, import mouse. And then every time you wanted to use that library, you would type in mouse dot, reload, something like that, mouse dot deactivate. But there was another way of importing in Python, which is from the mouse library, import reload. And then if you wanted to call the reload function, you didn't have to prefix it with the name mouse. This lets you load it in such a way that you loaded in that specific module, and so you didn't have to prefix it with anything.
So that std command that there's like from mouse import star, for example.
Exactly, exactly. But where are they really being imported is based on this. This is a line that brings them in, and this lets us skip using the library name.
Oh.
So if I commented this out, everything's going to be broken again, and there's no fix for it. So the # include is the equivalent of importing the Python library, and this one controls how you name the objects, how you name the modules that are in it. Yeah. So I'm going to go ahead and undo those. So that's the preprocessor directive. There are other ones. There's # def for defining. We may start using other ones, but not at the beginning. Basically, you just have to remember that if you're printing something, the arrows go that way. You use less than. So we're printing this message. How old are you in years? So all the arrows are going to go that way. When we're letting them type something in and we're using CIN, the arrows go the other way. Just kind of which way is the data flowing. Here we're reading something in, so we're going to put it in age, so the arrows have to go into the age variable. Here we're sending something to output, and so we're sending something to output, so the arrows have to go the other way. And it becomes second nature pretty quickly. So braces denote a block of code. In Python, you denoted your block of code just with indentation levels. In this language, indentation levels don't matter, but the braces do. So our special characters. / is a comment. So if I was being a good programmer, I would put some comments in my code. I'd put my name. I'd put the date. And then I'd say what this is. Well, I don't really know what it is. Class code to demonstrate stuff. All right, I'm going to leave off the description of what it really does. But there, we have a comment now. We could put comments for this, like this is the IO library. Iostream is the IO library we use. That's about enough. I guess I'll add a comment to this age line. Add one to our age. There. Okay, so we put some comments in here. There's a shortcut for writing age is equal to age plus 1. You can do age So say you had this line, age equals age plus 1. You could rewrite that as age plus equals 1. You Python users are used to that. And then you could just write it like that, age plus plus. What does that mean? It means add 1 to age and store it back into itself. So all three of these things mean the same thing. I don't care which one you use. If you're going to add 1 to something and then you're going to show your code to another programmer used to writing in C, they'd expect you to use that rather than that. But you know, that's how you learned how to do it in Python, so it's totally cool if you want to do it that way. Oops. So the cout object. What does cout do? It displays output on the computer screen. And then here they give a really fancy term for what arrow means. I think I skipped all the other symbols. They're calling this a really techie term. That's the stream insertion operator. Well, when I'm reading code to type in, I'm not going to say cout stream insertion operator. Hello there. I'm just going to say arrow, right? It's called in stream insertion because cout is a stream and it's inserting data into the stream. We'll talk more about streams in chapter 3 or 4 or something. So anyway, cout, arrow, programming is fun. What that does is it takes this string, everything between the double quotes, and it sends it to cout. But it doesn't go to the next line. If you saw our code here, when it says next year you will be something years old, those didn't appear on 2 lines. They appear in 2 lines in the code, right? We have that line of code and we have that line of code. But when we run it, it's 1 line of code. Next year you'll be 46 years old. It didn't break them up into 2, which is what it looked like it was going to do based on what we saw here. If we wanted it broken up into 2 lines, we would have to add another ENDL. I could do that. I could do another arrow ENDL, or I could use \n, which means the same thing. It just means new line. But it has to be a backslash rather than a /. This is what's
Does it have to be inside of the print?
Yes, because it is part of the string itself. Okay. So if I do use that to send it to the next line, it has to be a backslash. It has to be inside the string. That has to be before the quote. If I put it here outside of it, then it would identify it as some kind of syntax error, and I'm not one. Okay, we just give us a little red underline there. But now that if I do that and I run it, it's going to print those 2 things on 2 lines. Next year you will be, new line, 57 years old. So whenever you see /n, it's just like hitting enter. You know, goes to the next line. In Python, everything went to the next line automatically, and you had to struggle to stop the print statement from going to the next line. In this one, that's not the behavior. You have to specifically tell it when to go to the next line. I'm going to take that back out. I don't like the way it looked. Another thing you'll run into is if you don't put spaces in your strings, then when you run it, it may look a little bit odd, and you may want to go back and fix it. How old are you in years? I'm 45, and it says next year you will be 46 years old. Okay, if you don't, if you want it to look better, you just go and add spaces in the right place. I would want a space after the word be and before the word years. So I would put a space there, and I would put a space there. And am I going to count you off, give you a 0 if you're missing a space? No, but just make your code look good. If you like the way it looks, I'm going to like the way it looks. That sounds like a Paul Mitchell hairstyling commercial or something. Okay, so other symbols, opening and closing brackets. Those are used to hold the file name when you import a library with #include. Open and close parentheses. You use those to gather, well, you use those when naming a function. You have to have the parentheses after the function name, just like you did in Python. Opening and closing braces. You use those to mark the beginning and the ending of your blocks of code. Double quotes are for strings of characters, and semicolons end a programming statement in the fashion that we have already discussed. So this is one line of output, even though it's broken up into two. Cout. Programming is cout fun. Why is it one line? Because there's no ENDL there, and there's no /in there. If I wanted it to be broken up into 2 lines, I would add the ENDL there, or put a /in before the end quote. And you'll see me switch from one to the other. And I do have, there is some method to my madness on it. Here's what if I'm typing something like this, you don't have to type this, it's not part of the program. Please enter your name. And I want this to be, if I want it to go to the next line, it's faster for me to type /in quote rather than say quote, arrow, ENDL, like that, right? That was a whole bunch of extra characters. So if I already have a string open, I'll go ahead and use /in. But if I don't have a string open, like this, cout, arrow, your age is, end quote, arrow, followed by the age variable. And that's the end of the line. I could either do this, ENDL, or I could do arrow, quote, \n. You know, both of those would work. But in this case, I would just type ENDL because my fingers type that a lot faster than holding shift, you know, to get to the quote characters and / and stuff like that. That's just a personal preference. So when you're typing code in along with me, you're going to see me do that, and you're going to see me do that. I use /in if I happen to have a string already open, and I can just append that to it very quickly. But if I don't already have a string open because I just printed out a variable like that, I'll go ahead and use ENDL. Which they call a manipulator. The ENDL manipulator. You do not put quotation marks around the ENDL. Well, if you did, it just wouldn't look very good. I'm going to remove all those the STD : for there. But if I put quotes around it, what's it going to print? Here's what it's going to print. Don't make that change because it's wrong. How old are you? Next year you'll be 46 years old. ENDL. I don't want that. I'm going to take those quotes out. Anything inside of the quotes will be carbon copied onto the screen, right? It'll print them exactly, with the exception of the control characters, the escape sequences as they're technically called. /in is one of the escape sequences. There are other ones. /t causes a tab. So you can also use the /in escape sequence. Notice how we skip defining what an escape sequence is, to start a new line of output. So this makes 2 lines of output. The #include directive inserts the contents of another file into the program while it is being compiled. Doesn't change your file, it's just that while it's being compiled, it opens that file and reads it as over part of it. It's a preprocessor directive, which is not part of the C++ language itself. The preprocessor is shipped with the C language to make it easier to program. So that means that the #include lines are not seen by the compiler. Okay. Do not put a semicolon at the end of the #include line. Variables and literals. We're literally going to learn what variables are. What literals are they're the values that you type into the program code. Right here I'm asking the user for their age. But if I had wanted to set the age to something else, I didn't believe them, and so I set their age to 18. There, I have typed in a number into the source code, not as input. That's what's known as a literal. Sequence, it's something that is literally typed into the code. There are two kinds of literals you'll run into most commonly. Those are string literals, where name is equal to Bob, and you put that in quotes. The Bob is a string literal, and age is equal to 18. The 18 is a numeric literal. And I think somebody was asking a question, and I kept talking. I apologize, please. All right. Sorry about that. Okay, so that's a literal. A literal is either that's a literal right there. This is a literal. That's a literal. It means that's something that was typed in directly into the source code, and that's a literal. So a variable is a storage location in memory. It has a name and a type. You must be defined before you can use it. Int number. Number is equal to 5. Number is the variable. 5 is the literal that's going to be stored into it. Other textbooks will call it an unnamed constant. So the literal is a value that is written into the program's code. Hello there, that's a string literal. 12, that's an integer literal. So that 20. Int apples, apples is the variable. Apples is equal to 20. 20 is a literal. Identifiers. Identifiers are the parts of the language that you get to pick the names for. When we're looking at our code here, there are lots of things we don't get to name. I can't change that word using to, something else. Fred. That's going to break the code. But there are some things that I do get to name myself. Specifically, function names, like that, and variable names. If I didn't like the word age and I wanted to call it something else, like years, I can do that. Don't make this change because it breaks the rest of the program, right? But, if I didn't like the word age, I could replace it with years. If I did that, though, everywhere that the age variable was referenced, I would then have to change that to years as well. So I would have to type in years there, 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 and there. But I could do that. Variable names are for your purpose. They're not for the computer. The computer doesn't care if you call it Fred and Barney or, some obscene word or, a symbol of random letters or whatever. You can use anything there that you want to do. You just need to make them make sense to you. Yes, ma'am.
Is there a way to do like a search and change sort of thing, like what you have in Word on this program?
Yeah, there should be a couple of different ways of doing that. We ought to be able to do right-click. I'm getting myself confused with the Java editor. Oh, fine. I'm not spotting it. Is there no rename in this editor? You can always do find and replace.
Oh, there we go. Okay.
The problem with find and replace is like, let me say it's not a problem with find and replace. Make your variable names descriptive. Why do I say that? What if you just said, okay, I'm going to call my variable I, and then I'm going to call this variable A. And then later on you decide, oh, that really was a dumb name for that variable. This should have been something else. This should have been called account number. And so you go, okay, I'm going to do a find and replace. Edit, find and replace, change every A to the word account. Is that going to be a good thing? No, it's going to change every A in the file to the word account. And yeah, maybe there's a checkbox that'll say match, match words only, but it would also do it even in other functions, that you had defined further down in the code or whatever. So one good reason to not choose single letter variable names is just because if you went back in and you changed them later, it's more difficult to do so. Whereas if you give them unique names from the get-go, it's easy. But it's really bugging me. Visual Studio rename variable. Is there a way to do that automatically? If you click on a variable and click Control R, oh, well, isn't that intuitive? Let's see if that really works. Click on the variable, hit Control R, and then type in something else. No, doesn't do it in this version, but if you've installed Visual Studio something later than 2015, it would work. Sorry, I got my hopes up.
If you click age, if you look, all the other
They are all highlighted, correct.
something going on there.
So what that was telling me is that I could then type and it would replace them all at once. And I didn't see that to be the case.
Control R and then Control R again.
Get that shot. Control R, Control R. The key combination is bound to command refactor rename, which is not available. Okay, so here. I'm not getting it to work. Choose good variable names to begin with. If you get it to work, that's cool. So keywords. Keywords are words that you cannot use as your variable names because they're part of the language itself. I think I used a simile. You wouldn't name your kid a verb. You know? Well, we wouldn't name our variables bool or double or namespace or long or not. And most of the time that makes sense. Normally you wouldn't be tempted to. But there are certain keywords that you actually might feel like using. Class. I could see times when I might, you know, my class, what is this class? This is my C++ class. So class equals, quote, C++. It won't work because it's a keyword. Any word on this list can only be used for the purposes for which the inventors of the C++ language wanted. And if you try to use these as a variable name, it won't work. So if I go back into my code and I decide that this I should have been something called something really cool like the word class, that's going to break the code because that's a keyword. Fortunately, in this language, the keywords are blue. So as soon as you start typing something, okay. Fortunately, if you're using this editor, the keywords are blue. So if you start typing something and it turns blue and you didn't think that that was, you know, if you meant it to be a variable name, you know right off the bat that that wasn't a good variable name to choose. Same is true for function names. You can write your own functions. I'm going to make a function. Void do nothing. Parentheses, in parentheses. Cout, arrow, arrow, I am doing nothing. Backslash n. Okay, so yeah, I could call that function in my code if I wanted to. I made up that name. You know, I could have called it Tony Stark if I thought that that was a better method name, you know, function name. As long as I use the same variable name, function name when I called it down here, that would work. Again, function names are just for our convenience. The compiler doesn't care what we call this and what we call this as long as we call them the same thing, with the exception of they cannot be a keyword. So I could not use the word class there. I could not use the word if there. I cannot use the word using. Any of these things that show up in blue all throughout here would be illegal function names, just like they would be illegal variable names. Alright, so void nothing, cout I am doing nothing, and when I feel like calling it, I would have to call it by the same name. So when you invoke the function, you just use the same name as you gave that there. There are some rules for identifiers. And identifiers are names for variables, for functions, and for classes, which we haven't talked about yet. We won't talk about that until about halfway through the semester. Rule number 1, they cannot start with a number, with a digit. So you can't do 2016 taxes. You have to do taxes 2016. They cannot have a space. They cannot have punctuation or symbols with the exception of underscores and I believe dollar signs, although I think the text tells you that you can't put dollar signs in the names. So they cannot have punctuation except for underscore. And your prof says, oh, by the way, dollar signs also work, but nobody's used to seeing them. Other than that, so they can be like mixtures of letters and digits and underscores. When you name your variables, there's more than one way to name it. So like say you have the variable that is supposed to mean the height of the patient in inches. Well, okay, you could do this. Patient underscore height underscore in inches. You could do that. Or you could do patient capital H, capital I like that. I personally think that's easy to read. A lot of textbooks, especially for Java programmers, and a lot of other ones recommend this one. I don't care which one you use. General rule of thumb is just make your variable names meaningful, make them easy to read, and don't try to trip people up by mixing things up by changing lowercase l to 1. You know, you could really mess somebody up if you said that, you know, tax rate 1992, but you change that 1 to an L. Looks right. You know, yeah, maybe if you squint at it long enough, you can see it is, but you don't want to do that. And the same thing's true for 0 and uppercase O. They look too similar. So you just have to kind of make sure that the variable names that you're giving them have meaning, that they make sense, and that they're not hard to read. By the way, this one's known as Camel Case, like uppercase, lowercase. It's called Camel Case because it's got humps in it. I did not make that term up. I love underscores, but when I'm doing Java programming in particular, every other Java programmer in existence has been doing it this way because that's how the inventors of the language did it, and so I just play along and do it that way. I don't recall which way that the book does. I think the book likes that fashion. We'll find out. So variable names should represent the purpose of the variable. For example, items ordered. Oh, here they go with their camel case. They could have done items underscore ordered, whichever pleases you. The purpose of the variable is to hold the number of items ordered. It's probably going to be an integer. It's probably going to be a whole number unless somebody is allowed to order 1.5 automobiles. Identifier rules, it has to be an alphabetic character or an underscore. The other way you could say it is just no digits. After that, you can use any alphabet characters you want, numbers or underscores. Upper and lowercase letters are distinct, and I know that some of y'all have seen that. Whoops, in your code typing. Maybe not today, but I always see people do this. Int name, and then later on they'll say name is equal to whatever. Yeah. And understand why you do that, because you know you've been trained all your life that if you begin your sentence with a capital letter, but they have to match exactly, right? So if you did this with an uppercase N, that one better be an uppercase N, or you better make them both lowercase. Just make them match. It is a case-sensitive language. Why did I make name an int? That's dumb. Alrighty, let's go on. Valid and invalid. If I can hide this over here, let's see if we can say which of these are valid and which of these are invalid. Oh, great. You've already all seen them. Alrighty. Now, okay. Out of all of these, is this one valid?
Yes.
Yeah, it is. What if we took that and we made it a space? Would that be valid?
No.
Nope. How about the dot?
No.
It's not valid. However, you'll see that kind of notation where you have something dot something, but it means something completely different. It doesn't. That's not just a variable name if you see a dot in it. So that's bad. How about that one?
No good. We have
Right, exactly. How about that one? They say it's not legal. It is, but we're going to pretend that it's not because the book says so. And we can prove that to ourselves. I don't know why I always get hung up on this, but it annoys me that this particular textbook is wrong on that. And so, you know, if you want to do int sales, yeah, it likes that. But nobody else is going to recognize what that means. They're going to sit there staring, trying to figure out what the $sign means. And in a lot of languages, it's not legal. So we'll just stick with that. All right, we're getting close to the end of our time. Integer data types. An integer is a whole number. Ought to be the end of it. In Python, it is, right? You know, what is your data? You have 3 data types. You have ints, floats, or strings. In this language, you have 70 million different data types. And the reason why is that C has been just around so long that it's been through several different hardware iterations, going all the way back to 70. When an integer, the maximum value an integer could hold would be 255. And nowadays, the maximum value that an integer can hold is like 2 billion or something like that. But then if you need data that's larger than 2 billion, then you can use another integer data type besides int. So if we look at this, this is going to look absolutely silly for those of y'all who have used other programming languages. This is my favorite one. Unsigned long int. I love that term long. It's like the name for a panda. This is long. Okay, so these are all data types that contain whole numbers. What I basically want you to know is that an int is a great data type for whole numbers, and it can hold values from between -2 billion to +2 billion. If you need a number larger than that, you're going to use a long int. And you can even lose the word int on that. You just write long. And that'll hold huge numbers, right? I don't even know what that is, you know, a quintiquadzillion or something like that. So as far as our rules go, integer data types, int is the normal data type you'll use for values between plus and minus 2 billion. If that's not good enough, we're calculating the debt. You use long, which hold huge numbers.
Is it just long or long int?
You can leave the word int out.
Okay.
So I usually just type long, but you're correct. It is long int. There are also other integer data types. There's the byte, which can only hold values of up to 255. There's the short, a short int, which can hold a number up to 65535. Do you need to use bytes most of the time? No. Do you need to use short ints most of the time? No. Don't go, well, I want my program to be as efficient as possible, and if I use a int for something that is like only age, I'm wasting so much memory. Don't worry about optimizing your program like that. Unless you have a really good reason for using a byte or a short int, just use int for absolutely everything. And then if you need to make up something that'll hold something larger than 1 billion, go to long int. Then if we look at this chart, there is something else to note, which is that there are unsigned versions of each of these data types. What does unsigned mean? It means that it can't go negative. So if an int can go from -2 billion to +2 billion, an unsigned int can't go negative, so it starts at 0, but it goes up to 4 billion, right? It's like shifting the whole thing, you know. Instead of holding it where, you know, 0 was right here, and we had negatives and we had positives, I'll probably reverse that for you. Instead, I shift it over, and I have 0 to 4 billion. That's what unsigned means. Technically, it means that the way that this data is stored is in bits, and the first bit is called a signed bit, and if that bit is set, then the number is treated as a negative number. And if it's not set, it's treated as a positive number. And so that bit is wasted information if you don't ever need to go negative values. So anyways, are we going to be using unsigned in this class? Knock yourself out if you ever think you have the need to. But like I said, I just use int for everything until I find out I need to use something else. Have we talked about zeros and ones and bits and bytes and how to count in binary yet? All right. Good. We have a whole lecture coming up. Let's look at the next slide. I think I need to slow this down and think about what homework I am going to give you. We will call the turkey done. So integer types. Integer types are whole numbers. So here we go. Miles, 4276 or whatever that is. Whole number. The number of days is a whole number. Our checking, what is that, our checking account? I don't know. We have made a long journey of this many miles. Our checking account balance is -20. That's a drag. And on this many days ago, Columbus stood on the same spot. That's a pretty neat calculation. I'm not sure how they came up with that. I guess it's a good thing they put about. So these are whole numbers, but what if we don't really just want to limit ourselves to only having whole dollars in our checking account? You know, we go down to pennies. So ints are not good, or they just flat out do not support decimal points. We would need another data type, which is floating point data types. Oh, really? You want us to talk about chars for? I want to talk about floats. Okay. So there are, just like there are lots of different ints, there are also lots of different floating point types. But we're gonna concentrate on two of them. Floats are for shorter versions, kind of like ints are up to 2 billion. And then long doubles and doubles are for larger ones. More specifically, a float is stored as a 4-byte value. It means that there's 4 bytes used, and the byte is 8 bits. We'll learn what all those mean. Whereas a double is 8 bytes wide, meaning that you can store much more precise and much larger numbers in it. Just as a matter of course, always use double. Forget that the word float exists. Just always use double, because why would you use an imprecise counting scheme if you could use a more precise one? There are such things as floating point errors or rounding errors, where when you're adding numbers together, it starts introducing, mistakes when it does the math, and it sounds stupid. Computers shouldn't make mistakes. But yeah, when you're doing floating point math, you can wind up with rounding errors. You can, best thing to do is to declare everything as a double rather than a float, and then the impact of those errors will be minimized. So here we go. What they call a single precision. Don't know where they came up with that term, but it's 4 bytes. Will hold anywhere a number of up to 3.4 times 10 to the 38, or 3.4 times 10 to the negative 38. In other words, you can have about 37 point followed by 37 zeros in a number, or you can have a number followed by 37 zeros, or 38 zeros, right? So those are big numbers. But if you use a double, then you can go out to having 308 zeros in front of your number, or a number followed by 308 zeros. But even better than that, they support exponents. So you can hold astronomically large values. Floats support precision. If you remember precision from your chemistry class, how precise was my scale of about 8 digits? So if you type 0.1, 2, 3, 4, 5, 6, 7, 8, that's as precise as a float can get. Whereas doubles have 16 digits of precision. So you can get much more precise numbers that way. And we will do this a little bit more justice when we get back together. Yeah, that's a good stopping point. Let me make a little note to myself that where we stopped. Go back and do char, which we skipped. All right. So like I said, I'll post that homework assignment if you feel like working on it over the weekend. Great. If you don't, that's also cool. Are there any questions? Nope. All righty. I think we took roll. If you came in afterwards, hey Daniel, I want to give you something, so don't run off yet. I'm sorry, I've forgotten your name.
Jeannie?
Okay. And I keep calling you Jean rather than Jeannie.
It's okay either way.
Okay. I did notice your absence, and I'm surprised you've been here every time, so I'm glad you're here.
Do we need to send our
I forgot to make a Dropbox for everybody. So if you haven't logged your computer off, or even if you have, I apologize for that. Let's make a Dropbox. Yep.
We've only this is our second program, right?
That's correct. We did one, we did A, so this will be program B. You could just upload it the next time you come in if you remember to do so. I'll probably give everybody credit for it no matter what, since I've already let people slip out of here. But since you're there, you may as well log back on your computer.
Okay, then.
All right, so if you refresh your Dropbox, your assignments folder, you'll see folder B. Please upload your CPP file for today. Or do it next time you come in, if you want to.
And I will see all you on Tuesday. It's
You basic programming? Yeah, okay.
projects. Yep. It's okay. So.
CPP? Oh.
Yep. Not really bought the book yet, but I just posted a free PDF of it on the class discussion. My computer at home has like lifetime virus protection, so I do each semester to go online and I go to all these really shady websites that download free PDFs, and I wipe my computer out. It makes Google Drive very easy. If anybody still needs the book, I just downloaded a free PDF of it onto the class discussion.
Oh, you are. Wow, you are cool. You are. No. Keep it exclusive. Wow, you're cool. Yeah.
And then age.
Yeah, I'm good.
City color, etc. She was, anytime I get behind on the typing, just tell me to slow down. Or your horses. So it did help, so we go ahead and bring her up there tomorrow.
Oh, the little plaything.
Yeah.
Oh, so,
There we go.
okay, cool.
Pardon me?
Yeah, I'm trying to like do the thing, but so it gets to this point, and then it doesn't have the type.
Okay, yeah, so nothing is where we expect it to be, but if we do use Solution Explorer, it will always bring that back up so we can start working. Right, and then add, let me bring the code back up. You can do the type of it.
I have it.
Okay, cool.
I have it. Thank you. So
Sure. Yes, sir.
I counted absence.
Oh, okay. Let's fix that.
Secondly, the lists.
Okay.
So I come direct from work. So
All right. So, pardon me. Remind me.
amen.
Oh, I thought I counted. Oh, yeah, you're right. Sorry. I just thought you were here, but I did mark you as absent. Okay. Yeah.
No,
Gotcha, Eamon. You were a little late,
I
right.
come from work directly, so sometimes.
I understand. Yeah. Yeah. So sometimes you will be.
Yeah.
That's okay.
Thanks so much.
Sure thing.
You said we can work over the Tuesday homework.
Right. I'm going to post the
Okay.
homework. So if you want to start it before Tuesday, that's cool.
So, thanks so much.
Sure thing.